change of state of matter and energy involved in state changes. Imagine that you are slowly heating a piece of ice, initially having a temperature of -25 degrees Celsius in its physical state. As heating continues, the temperature of the ice increases from -25 degrees Celsius to 0 degrees Celsius. At this point, ice begins to melt. Melting continues due to further heating, but the temperature remains at 0 degrees Celsius until all of the ice has melted. The liquid at this point increases in temperature until 100 degrees Celsius, which is the normal boiling point of water, is reached. Another phase change occurs at this point as liquid water turns to steam. While vaporization, or the boiling, is taking place, the temperature remains the same until all the liquid is converted to steam. Continued heating raises the temperature of the steam. But you know what? Some solid change to gas without melting first, like mothballs and iodine crystals. These are some examples of matter that changes from solid to gas. The process by which a solid is converted to gas without passing through the liquid state is called sublimation process. As heating continues, the absorbed heat causes a change of phase, not a change of temperature. For melting ice, this heat referred to is the heat of fusion, the heat required to melt 1 gram of a solid. At its melting point is its heat of fusion. For ice, 80 calories of heat energy is needed to convert 1 gram of ice to 1 gram of water at 0 degrees Celsius. Thus, 80 calories is the heat of fusion of ice. Solidification is the reverse of melting. The amount of heat given off as 1 gram of liquid changes to a solid at the melting point. It is the heat of solidification. Since melting and freezing are reverse process, the magnitude of the heat of fusion and the heat of solidification are equal. The same changes in the energy occur when a liquid is vaporized. The amount of heat energy needed to convert 1 gram of a liquid to gas at its normal boiling point is its heat of vaporization. When the gas condenses to the liquid, an amount of heat equal to the heat of vaporization is given up by the gas. This heat is transferred to any object in which the vapor condenses. The temperature of the condensing liquid does not decrease until all of the heat of vaporization is given up. The heat released when 1 gram of vapor condenses of liquid at the boiling point is the heat of condensation. Condensation is the reverse of vaporization. Thus, for a specific substance, the heat of vaporization is equal to the heat of condensation. Got it? Alright, so this time let us have sample problem pertaining to the equation that we will be using in order to change the phase of matter. So, sample problem number 1, how many joules of heat are released when 25 grams of benzene vapor condenses at its boiling point? The heat of vaporization in joules of benzene at its boiling point is 393 joule per gram. So for the solution, this is what we are going to do. We need to identify first the given. We have a mass, which is 25 grams, and we have the heat of vaporization, which is 393 joule per gram. So we are going to compute the amount of heat released, and that will be Q equals to M times HB, wherein HB is the heat of vaporization. So plug in the given to the formula. We have 25 grams as the value of mass. The heat of vaporization is 393 joule per gram. So as you can see, we can cancel out this unit and this unit. So the remaining unit is joules. So when you multiply 25 to 393, you will get 9,825 joules of heat. So that is the heat release in the given problem. Alright, so next, let us have sample problem number 2. How many kilograms of carbon tetrachloride can be vaporized by the addition of 200 kilocalories of heat at its boiling temperature? the heat of vaporization here of carbon tetrachloride is 46 calories per gram. So we are going to have the solution now. So the heat added in calorie is 200 kilocalorie, but we need to convert this to calories, and 1 kilocalorie is equal to 1000 calories. So for the conversion, we will have this equation: 200 kilocalorie times 1000 calories divided by kilocalorie, or 1 kilocalorie. So as you can see, we can cancel out this and this. So the next thing that we're going to do is to multiply 200 to 1000. So you will get 200,000 calories. That is the heat added in calories. All right. So for the solution, this is what we are going to do. First, get the mass of water, but that is the unknown, the mass of water. But our formula is Q equals to M times HB. So we need to derive the formula of mass from this equation. So we are going to write the equation Q equals to MHB. And since M is the unknown, so we're going to encircle the partner variable of the unknown, which is HB, and we're going to write it here. And if you write it here, you're going to write it here also. That's why I can cancel out this and this unit. So the formula now for mass is equals to Q divided by HV, which is the heat of vaporization. And then now that we have already the formula, we are going to plug in the given. So M is equals to Q, and Q is equals to 200,000 calories divided by HV. HV is 46 calorie per gram. So we can cancel this calorie and this calorie. So the remaining unit is gram. So 200,000 divided by 46, mass will be equal to 4,348 grams. Or if we're going to express that in kilogram, mass will be equal to 4.35 kilogram. So that is the answer for our previous sample problem. The next, let's have another sample problem. How many calories are required to vaporize 1 kilogram of water at its boiling point? The heat of vaporization of water at 100 degrees Celsius is 540 calories per gram. So the first thing that we're going to do is, of course, identify the given. So for this one, we have a mass of water which is equal to 1 kilogram. And we all know that 1 kilogram is also equal to 1000 grams. We also have the heat of vaporization, which is equal to 540 calorie per gram. So our formula is heat equals to M times the heat of vaporization. So plug in the given. Mass is equals to 1000 grams. The heat of vaporization is 540 calorie per gram. So basically, we can cancel out grams and grams here. So the remaining unit is calorie. So 1000 times 540 will give you 540,000 calories of heat. Alright, so this is the amount of heat required to vaporize 1 kilogram of water at its boiling point. Alright, so let's have another sample problem. This time, our problem is how many calories of heat are required to convert 300 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. So we need to know the procedure, how we can compute the amount of heat required to convert 300 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. So let's have the procedure. Procedure, you should have first the heat of fusion and then the heat of vaporization, as well as the specific heat of ice and water, since we're going to convert 300 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. So for the ice, here is the heat of vaporization, 80 calories per gram. And then the specific heat of ice is 0.5 calorie per gram degrees Celsius. So remember that the heat of vaporization, heat of fusion of ice is 80 calories per gram, and then the specific heat of ice is 0.5 calorie per gram degree Celsius. Now, we also need the heat of vaporization of water, which is 540 calorie per gram. And then the specific heat of water is 1 calorie per gram degree Celsius. So we are now going to have the solution. So for the solution, since it is ice, so we need to heat ice from negative 20 degrees Celsius to its melting point 0 degrees Celsius. We need to follow the diagram or the graph that I showed you in the first part of this video. So to heat ice from negative 20 degrees Celsius to its melting point 0 degrees Celsius, we need to use this formula, Q equals to mc delta T, wherein Q is the heat, m is the mass, C is the specific heat, delta T is the change in temperature. Delta T is also equal to TF minus TI, wherein TF is the final temperature, TI is the initial temperature. And in this problem, we have a change in temperature already, which is equal to 20 degrees Celsius. So all we need to do here is plug in the given. So Q is equals to mc delta T, m is equals to 300 grams, specific heat of ice 0.5 calorie per gram degree Celsius. The change in temperature is 20 degrees Celsius. So what you're gonna do is cancel out the unit that we can cancel. So grams and degrees Celsius. So since we're computing for the amount of heat, the only unit that we need is the calories. So since that is the remaining unit, that means we can proceed with the multiplication. So 300 times 0.5 times 20 will give you an amount of heat which is equal to 3,000 calories. Alright, so that is the amount of heat needed to heat ice from negative 20 degrees Celsius to its melting point, which is 0 degrees Celsius. Then next, to melt the ice at 0 degrees Celsius, we will be using this formula, Q equals to m times HF, wherein Q is the heat, m is the mass, and HF is the heat of fusion. So mass is equal to 300 grams, heat of fusion is equal to 80 calories per gram. So we can cancel out this and this unit, which is grams and grams, and then the remaining unit is calories, which is a unit of heat. And then we'll proceed with the multiplication. 300 times 80 will give you 24,000 calories of heat. That is the amount of heat needed to melt the ice at 0 degrees Celsius. Alright, so next, we are going to heat now the water. Since the ice melted already, so we're going to heat the water from 0 degrees Celsius to its boiling point, which is 100 degrees Celsius. And the change in temperature here is equal to 100 degrees Celsius. Alright, so Q equals to mc delta T, again, is the formula that we are going to use in this particular part of the solution of this problem. So the mass again is equal to 300 grams. The specific heat, if you will notice, earlier we have 0.5, but now I have 1 calorie per gram degree Celsius. Why? Because in this case, we are no longer using ice but water. And the specific heat of water is 1 calorie per gram degree Celsius, and the change in temperature is 100 degrees Celsius. So what we're going to do is cancel out the unit, cancel out grams, and degrees Celsius, and then we can proceed with the multiplication. 300 times 1 times 100, that will give you 30,000 calories. So this 30,000 calories of heat is the heat needed for water from its 0 degree Celsius temperature to bring it to its boiling point, which is 100 degree Celsius. So we need 30,000 calories of heat in order to heat the water from 0 degree Celsius to its boiling point, which is 100 degree Celsius. Get it? We're not yet done. So next, the next process is we are already on this stage, we need to vaporize the water at 100 degrees Celsius. So to vaporize the water at 100 degrees Celsius, we'll be using this formula. Q equals to M times HV. Q again is the heat, M is the mass, HV is the heat of vaporization. So the mass is 300 grams, the heat of vaporization is 540 calories per gram. So we can cancel out this unit and this unit, so the remaining unit is calories. And then the next thing that you're going to do is multiply 300 to 540 calories, and that will give you 162,000 calories. So this 162,000 calories is the amount of heat needed to vaporize the water at 100 degrees Celsius. Alright, so for the final solution, we're going to compute for the total heat energy required in order to convert 300 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. So these are the amount of heat that we compute a while ago. So we have 3,000, 24,000, 30,000, and 162,000 calories of heat. So in order to get the total heat energy, you just have to add all of this. So 3,000 plus 24,000 plus 30,000 plus 162,000 calories of heat will be equal to 219,000 calories. Alright, so this is the total heat energy needed to convert 300 grams of ice at negative 20 degrees Celsius to steam at 100 degrees Celsius. Got it?